In the second part of today, we're going to talk about program arguments. You know that ls can take -l in order to display details of a directory. What you've learned to do so far is launching your binary. But if you added arguments, nothing would change. Let me just quickly rewrite my super main. I'm going to display bonjour, hello in French. I think we can all agree to say that whether I do this or that, it'll always display the same thing. You don't know how to retrieve what I wrote yet. And by that, I mean the parameters that your binary could take. We told you that your main code could take 2 arguments. It's thanks to those that you'll be able to retrieve the parameters that can be passed to your binary. argc represents the number of parameters that you can pass to your program, while argv is a char star star. In other words, a string array, which will contain those parameters. So, I'm going to display my first parameter. And then a line break. Recompiling. Here I can see that even without arguments, a.out is displayed. Because your strings array's first element is your binary's name, if I launch my binary from somewhere else, argv square bracket 0 would have that binary's path and its name. So in argv's first box, you have the binary's name, the first element on your command line. If I want my first argument, I have to access argv square bracket 1. But if I don't set an argument, I'll get a segfault. We cannot read into an empty array. However, if I do this, it works, and if I do that, it still works. But if I do this, I'll only display the first argument. The trick is to use inverted commas to regroup multiple arguments within one same string. We should say that argc is always at least equal to 1. As argv square bracket 0 is always filled. Then you'll be able to pass options to argv square bracket 1, just like ls does, with its option -l or any other binary with options. All of this will allow you to be a little bit more efficient in your program, because you'll be able to use conditions. For example, let's ask for argv square bracket 1 to be displayed only if argc is equal to 2. This way we avoid a segfault, because we're testing whether there's an argument present, and we allow it to be displayed if it exists. This way we don't need to test whether the string exists. Thanks to argc, we can know how many arguments we have. We can also use argc to display one by one parameters passed to your program by scanning the array. This could also allow us to indicate whether the program needs an argument. And in the case where they don't exist, tell the user that the program needs a certain number of arguments. We can also warn them that the program takes 22 as an argument. This way we can inform the user on how to use your program properly. With these examples, you can begin to imagine the number of possibilities available to you to make your program more user-friendly. Still, watch out for seg faults. They'll force you to anticipate what the user might try to do. Up till now, you didn't have this constraint. You'd launch your binary, being sure that you and only you could choose how it behaves. But now that you're allowing other users to interact with your program, you'll never be sure of what they'll try and pass as arguments. But we know what we're doing, and we know what you might forget. So here's a piece of advice. Be careful, and bear in mind that you'll never be able to guess everything the user might pass to your program. So test your arguments thoroughly and check everything you do.